as it a parasite symbiosis. The worm will continue its mature state inside the bird's body, completing the life cycle inside another host. I think that is all from me. Thank you. I hope you really enjoy it and gain some knowledge about symbiosis relationship. Okay guys, see you in another video. Bye.
Assalamualaikum warahmatullahi wabarakatuh. I, Anis Akila, will continue my group presentation with part 45.2 Community Development. So, under Community Development, we learn about ecological succession, which could be defined as a change within a community involving a series of species replacements. So, under this, it could be divided into two parts, which is primary succession and secondary succession. We start with primary succession. Primary succession is formation of soil from exposed rock due to abiotic factors. Abiotic factors such as wind, water, and etc. This particular succession would only happen to a community where there is no base soil originally present there, such as following after a volcanic eruption or a glacier retreat. So next is secondary succession. It is a disturbance-based succession where the community would have a progressive change from grasses to shrubs to a mixture of shrubs and grasses. So this succession will happen to a community where there is already soil present there, as when a cultivated field will return to their natural state. Okay, in this figure, we could see that primary succession has 4 stages. It starts out with rock or lichen stage. We could see that here, there is no base soil present in the community at the moment. And then it will gradually progress through 3 more stages: shrub, low tree, and high tree stage. Next, this figure is secondary succession. We can see that in this succession, the initial stage will begin with small and short-lived species and gradually proceed through stages of species with mixed size and lifespan until it becomes predominant with large long-lived species. So here, the first producer here that inhabit the community is called pioneer species. Pioneer species are the first producer that inhabit a community after a disturbance happens. And then there are progresses through series of stages over the time until it end up with a climax community. So climax community could be further explained under models about succession. So under models about succession, in 1916, F.E. Clements proposed that a succession in a particular area will always lead to a mature and stable community, which he called climax community. And then F.E. Clements also made 3 more hypotheses about climate and soil condition that could affect the succession in the result. So the first hypothesis he made is about succession in particular would determine whether the succession would result into a desert or a type of grassland or any particular types of forest. This is the reason why he said that in the northern latitudes, the climax community is coniferous forest, while in the tropics, tropical rainforest would be the climax community. Next hypothesis is the soil condition. Soil condition, like shallow and dry soil, would produce a grassland, whereas rich soil of a rich bank, of a river bank, would produce a woodland, where a prairie would be expected. The last hypothesis that F.E. Clements made is each stages facilitate the invention and replacement by organism of the next stage. That is all for part 45.2. We continue with part 45.3, dynamics of an ecosystem. So in dynamic of ecosystem, we know that ecosystem is composed of the interaction between a biotic and biotic component, which is a living and non-living component. So the example of a biotic component here is atmosphere, water, and soil, while biotic components have producers, herbivores, and carnivores, and also decomposers. So this biotic component could also be categorized into two categories according to their food source. The two categories are autotroph and heterotroph. So first with autotroph are organisms that require only inorganic nutrients and outside energy source to produce organic nutrients for their own use or for all the other members of the community. So producers are a type of autotroph because they make their own food from inorganic nutrients from the solar energy through photosynthesis. So autotroph also include photosynthetic organisms such as algae and land plants. So they also possess chlorophyll and carry on photosynthesis. A member of autotroph is also chemosynthetic, where autotrophic bacteria obtain energy by oxidizing inorganic compounds, such as ammonia, nitrites, and sulfides. So they use this energy to synthesize organic compounds. So this chemo-autotroph could be found in a community where there is no sunlight available. They could be found supporting a community inside a cave or hydrothermal vents along deep sea oceanic ridges. Next is heterotroph. Heterotroph are organisms that need pre-formed organic nutrients they can use as an energy source, and we call them as consumers. Under consumers, we have herbivores, carnivores, omnivores, detritivores, and decomposers. So, like we know, herbivores are animals that feed on producers or plants, while carnivores are animals that feed on other type of species of animals, while omnivores are consuming both plant and other type of animals. So detritivores are organisms that feed on detritus. Detritus consist of decomposing particles of an organic matter. Next is decomposers. Decomposers such as bacteria and fungi, including mushroom, they acquire nutrients by breaking down that organic matter, including animal waste. In this diagram, we could see of all biotic components illustrate that every ecosystem is characterized with two fundamental phenomena. So the first phenomena is energy flow, where its energy flow start when a producer absorbs solar energy from the sun, and chemical cycling begin when the producer take in inorganic nutrients from the physical environment. Therefore, via photosynthesis, producers make organic nutrients or food directly for their own use and indirectly for the other population within the same ecosystem. That's all from me. We continue with my group meet.
Okay, now I'm going to talk about dynamics of ecosystem, which explain about energy flow, trophic levels, and ecological pyramids. So energy flow is the amount of energy that flows through food chain. Only a portion amount of energy is transferred, the rest dissipates into environment as heat. So as you see from this picture, this is an organism which receives organic nutrients from food. These organic nutrients are then used for cellular respiration to produce ATP, which then converted into heat to environment. A large portion of energy is also released through death, excretion of metabolic nitrogenous as urine, and defecation of feces to the detritus feeders. The detritus feeders is heterotrophs which live off dead organisms. The leftover of heterotrophs are then used by decomposers to compose organic nutrients and recycle them for the continual of the whole process. So this is the energy pyramid, which shows that the sun as the primary source of energy of whole life. And this is what I explained just now, which is the organic nutrients from the organisms will go to the decomposers to recycle the nutrients and continue the process of energy flow. So a large portion of energy is lost as heat. This process is related to the laws of thermodynamics, which states that energy cannot be created or destroyed, but it can change from one form to another. The second law of thermodynamics states that energy cannot be changed from one form to another without loss of usable energy. So this is the example of energy flow. Down here you can see that detritus and decomposers. This is the autotrophs, and which is the producers, and the primary consumers, secondary consumers, tertiary consumers, and so on. Okay, for trophic levels is a level of nutrients within a food web or chain. So from this picture, we can see that producer is the first trophic level, primary consumers is the second, secondary consumer is the third, and tertiary consumer is the fourth, and so on. Ecological pyramids show the relative amount of various parameters such as number of organisms, energy, and biomass across trophic levels. So from this example, you can see that each trophic level has its own biomass, and only 10% energy of trophic levels is available to the next trophic level. You can see that autotrophs has greater amount than herbivores, but from the previous slide, it didn't make sense because each tree must contain many amount of caterpillar, right? This is what makes the ecologists hesitate to use pyramid to refer to, because of course it depends on its size, whether it's big or small. Like this caterpillar can be as small as caterpillar or as big as elephant. So it depends. The pyramids of biomass eliminate size as factor because biomass is the number of organisms multiplied by dry weight. Like I say, autotrophs supposedly and expected to be greater than herbivores, but in aquatic ecosystem, you can see that herbivores is greater than producers, which is terbalik dengan apa yang saya terangkan tadi. Zooplankton as the herbivores is much more greater than phytoplankton, which is the producers. So this is called as the inverted pyramids. Okay. One more problem is the pyramid rarely include decomposers, which is important in the whole ecosystem. So that's all from me. Thank you for joining my class today. So see you next time.